Hey folks, so this should be the third and hopefully the final video in section 8.4. And so let's go down to operations that we can do with vectors. So we're going to be looking here at first, we're going to be looking at how to add and subtract vectors. We'll always use just combine like terms on that. And then secondly, we'll be looking at how to multiply a scalar, which is just a constant. It's a fancy word for constant. And all we're going to do there is we'll just distribute. Quite frankly, this is something you're very comfortable with. All right, so let's just jump straight into some examples. Notice that I have been given two vectors, vector u and vector v. And the first thing I'm going to do is I just simply am going to add those two vectors. So we're combining like terms. So that means you're going to add the horizontal pieces and you're going to add the vertical pieces. Add the x's, add the y's is essentially all you're doing there. And so when you take your 6 plus a negative 14, that's where you get negative 8, and a negative 3 plus an 8 is going to give you 5. All right, now the second thing is let's multiply by a scalar. And so we're going to take vector v and we're going to multiply it by negative half. You can do this by distribution. So take each of your components and multiply each component by a negative half. So this is going to give you the vector 7, negative 4. Part C kind of has a little bit of both, and so we'll follow the order of operations. The first thing we'll do is we'll multiply vector u by 5. So we'll take each piece and multiply 5. And the second thing we'll do is we'll take each piece of v and double it, multiply by 2. And then after we've done that, we will add our like terms together. All right, so when I take vector u and I multiply by 5, that's going to be a new vector that is 30, negative 15. When I take vector v and double it, that's going to be negative 28, 16. And then when I combine those two by addition, combining like terms, that's going to be 2, 1. A unit vector is a vector that only has a magnitude of 1. Now we've got two special unit vectors. One of them is called I, which is the vector 1, 0, so I'm only going 1 unit to the right. And then we have the vector j, which is going 1 unit up. So I and j are two special position unit vectors. Now, what we can do with this then is that we can have our old method of writing a vector using our pointy brackets and our coordinate on the inside. This now can also be written as a new form, AI plus BJ. So if you think about why that works, let me map this out for you really quickly. A times I would be 1, 0 here, plus B times J would be 0, 1. Let's just work backwards. So we know how to multiply a scalar now, and we just distribute. So A times 1 is going to be A0. Plus, when you distribute B, that's going to be the vector 0, B, oops. And then when you combine like terms, that's going to be vector AB. So it's really easy to see once we do that this old way of writing is the exact same thing as AI plus BJ. So it's just a different way of writing your position vector. Another operation that we can do is called the dot product. This is a special type of product. Interestingly, when I find the dot product of two vectors, I don't get a new vector. I just get a real number. So it's kind of interesting. So how do I find this dot product? Well, if I want to take vector u and vector v, and I want to multiply them, the way I read that is u dot v. I don't read it u times v like we would read a regular product. We read that u dot v. How do I find that? Well, we're going to take the first two components, my A times my C, our second two components, my B times my D, and then I'm going to add those together. So in English, basically, we're taking the products of the first components, the products of the second components, and then we're adding those together. All right, so let's find the dot product here in example number 5. So in example number 5, let's multiply the first two components, multiply the second two components. That's going to give me a 10 plus a negative 8, which is 2. So the dot product for part A is 2. For part B, take the product of the first two and the product of the second two, add those together, and you get 0. The dot product can be either positive or negative or 0. We'll talk about what that means here in just a moment. But the real reason we like to learn how to do the dot product is so that we can find the angle between two vectors, finding the angle between two vectors. And so here's how to do that. First thing, it's a 4-step process. First thing, get the dot product of the two vectors. Secondly, get the two magnitudes. Thirdly, plug it into this formula right here. Now let's pause for a moment. If theta is the angle between two vectors, where this is just a normal angle, then the following holds true. Cosine of theta is equal to the dot product u dot v divided by the two magnitudes multiplied together. So we're just going to take our dot product divided by the product of our magnitudes. Let's plug that in, and then let's chug along to find out what our theta is. All right, so have that little 4-step list handy as we go into part A of example number 6. So the first thing that we're going to do is we're going to find out what is u dot v. Well, u dot v is going to be 20 plus negative 36, which is a negative 16. All right, so that takes care of step number 1. Step number 2, get the two magnitudes. Now, I've already drawn a picture. Please remember, whenever you have legs and you want magnitudes or thetas, draw a picture. When you got legs, draw. When you got legs, draw. All right, so we need to find the radius of both of these. I've already drawn them for you. So I'm just going to go ahead and do the math. And we've got 13 for this one and 5 for this one. So the magnitude of u is going to be 13. The magnitude of v is going to be 5. So that takes care of step number 2. Step number 3 says we're going to plug it into our formula. Everything that we know now, we're going to plug into our formula. So up on top is going to go a negative 16, and on bottom is going to go this 13 times 5. All right, so when I reduce my fraction, that's going to be a negative 16 over 65. Sorry, not reduce, when I simplify. And then the last thing we do for step 4 is we got to chug. We got to find out what theta is. Well, how do you find angles? You use inverses. All right, so what we're going to do then is use the inverse cosine of negative 16 over 65. This is definitely not a memorized unit circle value, so go ahead and pull your calculator out for that. And when I plug it in, I will get 104.2500 degrees. All right, let's do one more example of that. So here, u dot v is going to be 0 because 24 plus negative 24 is 0. Again, I've already drawn pictures for you. We need to find our magnitude. So this guy is going to be 5 here, and this one's going to be 10. Again, if you don't believe me, pause the video and just do the Pythagorean theorem. Let's plug it into our equation, our formula. And so this is going to be 0, my magnitude on top, divided by my my dot product on top, divided by my two magnitudes, which is going to be that 5 times 10, which is where I got the 50 from. All right, so my cosine theta then is equal to 0. And so I really don't even need a calculator for that. Cosine is equal to 0 at 90 degrees. And so let me stop there for a moment. Cosine is equal to 0 at 90, but it's also equal to 0 at 270. But remember what this said. This is a normal angle. This angle is going to be between 0 and 180. So 270 isn't a normal angle, and so we're not going to use that option. And so then we can say And since my theta is 90, this is going to be perpendicular. That's the symbol there for perpendicular vectors. The other name for perpendicular vectors is they're called orthogonal. I've actually looked up the pronunciation. Orthogonal is correct, and orthogonal is also correct. So, tomatoes, tomatoes. All right. What does the sign of the dot product tell us? And I mentioned that up here when we said that the dot product can be positive, negative, or zero. It does tell us something. When my dot product is positive, I have an acute angle. When my dot product is zero, I have a right angle. And you saw an example of this right here. And lastly, when my dot product is negative, I have an obtuse angle. And you saw an example of that right here. My dot product, which is all the way up here, was negative, and my angle ended up being obtuse. All right, folks, that's the end of this one.